So this video we're looking at water waves, specifically water waves, and we're looking at transmission and refraction. So typical situation where you have waves in the deep and they're approaching a beach which is much more shallow. So we tend to want to create a distinction between deep and shallow, so it's a sharp distinction and it makes it a bit easier for us to initially learn these concepts. But if we have water waves coming from the deep, trying to get these spacing pretty well even, we have a wavelength here, we'll call it wavelength 1, and we have a velocity of the wave, v1. Now in the deep we can consider that a much more water and much more freedom to move. Therefore, as we go into the shallow, there's much less freedom to move. It's going to make it harder to travel, and you're going to have a decrease in the speed. So the wavelength has to shorten. Remember, the frequency doesn't change. So the frequency does not change as it goes from side to side. It's the same. That means the number of wave crests passed a point per second. The frequency doesn't change, but that means the velocity has to drop. Call that V2. And if the velocity drops, then they're going to catch up each wave that comes up into the into that change of depth. It's going to catch up because these ones are still travelling fast. These are travelling slower. So the next wave coming in will be closer to it, the previous wave front, than it was. Hopefully you catch that. Rewind and go again if you're not sure. So anyway, the wavelength 2 is going to be smaller than the wavelength 1. V2, velocity 2, is going to be smaller, and that has to hold true for V equals F lambda. If F is the same, wavelength decreases, V decreases or decreases, V decreases, wavelength decreases. Okay, trying to get the video short. Now that's a direct example, going straight on. What if we have the situation where it hits a boundary? Here's our boundary between deep and shallow. Here's our boundary between deep and shallow. What if it hits a bit of an angle? So this time we're going to have our wave fronts coming in like this. Boom, it hits there, boom, it hits there, trying to keep that, again, wavelength the same. Now, this is going to be, I'm going to draw a normal, and I'm going to draw a wave direction. Here's our wave direction. Here's our normal to the surface. This may seem a bit funny doing this outside of an optics side. You may not have done the optics side, but just go with it. The normal is meant to be 90 degrees to the boundary. What we're going to get is, again, a slowing down, and it kind of drags it around. So you've got this boundary here. As the wave hits it, this leading edge that hits into the boundary is going to be going slower. Therefore this one here is going to be going faster, and that in effect overtakes it. So this side is going to come around and this one's not going to come around as much. So the side at the bottom here is going to overtake, and what you're going to get is this effect. Okay, let's draw it's bending towards the normal. There's our new wave direction, and we're going to remain perpendicular at the same frequency, and you have a decrease in, you can have a little one there too, you have a decrease again in the wavelength. If you do this wrong, you'll see an increase in the wavelength. So if you try and bend it that way instead of the correct way, you'll see an increase in the wavelength and it'll mess it up. Okay, so that's refraction. Easiest way to deal with it, once again, is to draw these wave directions and treat it like optics. And when you get to optics again, that'll make more sense, unless you've already seen that. You can watch the videos in whatever order you like. And so treat it as optics and draw these wave fronts perpendicular to the direction of the propagation of the wave. One final point, and this is condensing a whole second half of the video into 2 seconds, is that if you go that direction into this medium, you're reversing the situation. Okay, so you're going from a harder or slower speed to a faster speed in the deep, and therefore it'll bend back the way like that. Okay, there you go, you work it through. Feel free to send any questions through, and if I can get to them, I'll get to them in my busy schedule. But I do like making the videos and answering questions. Thanks very much.